Welcome back. This is the continuing work I'm doing on the kind of pickup mechanism. It's like a practice pickup mechanism for algae. It's a design, kind of a looking at a fake design, right, to kind of help you students with things you should be looking at and processes you should be using to do a design, right? And hopefully you can apply this to the upcoming season. So in the previous videos, I developed this 2D sketch of a 4-bar linkage and came up with kind of initial hard points for the two arms. And then in the video after that, I used GIM, G-I-M, a small piece of software to refine that design. And I'm kind of set this up so you can see what happened between these two designs. Today I'm going to carry this a little bit further into Inventor. I'm going to set up an assembly and see how we can iterate that assembly to get even better movement for picking up the algae. But if you compare what happened in GIM, or how the design modified, you can see here in our initial sketch we had our two location points of the arms. The outer point was higher and the inner point was lower and well inside. You can see when we did our analysis with GIM, this point stayed relatively the same and moved out a little bit, but the inner point moved up and in more towards the center of this rail. So it's up somewhere around here. You can see the links. They're originally this inner link and the outer link are probably around the same length. But they're both a little bit shorter, and I think these, especially this outer link, I'm defining the outer link by which point is more towards the exterior of the robot, and this point is more towards the interior. So this would be the inner link, this would be the inner point, this would be the outer point, and this will be defined as the outer link. It's just a naming convention I came up with. So these two links are one a bit different length, but this length is a little bit longer, and you can see the I started calling this the claw base. This claw base, the attachment points are quite a bit different, right? We want this to swing and be horizontal, and this attachment setup is a lot different. This is more triangular and this is more square. So that's kind of the changes. Now what I've done is I've constructed some generic arms, a generic base, which is what attaches to this rail, and a generic claw base. And I've tried to set these up so they're parameterized so I can move them. So when I assembled these together, I could make modifications easily. So I'll show this one at a time. So I have this base, and again, I didn't put too much design thought into it. I just wanted to be able to move these points, and I thought that in some way I'm going to, bolt to this rail of the robot. So I'll probably bolt vertically and horizontally. But again, it's just a very conceptual looking design. Okay, so that's the base. The claw base is also a fairly conceptual design. It is just to, attach the two arms. And it has this platform which the design of the claw would attach to. And again, this would probably change quite a bit. But I wanted to get something down design-wise. And then the two arms, they're actually the same geometry, but since I parameterized the geometry, I copied the file and renamed one. And I renamed one to outer arm and another to inner arm. And like I explained, outer arm is defined by the point. So outer arm comes from the outermost point on the base. And then inner arm is here. And I've done some, from the gym setup, I've made some modifications to the geometry to get what I feel is a better I'll call it a better mechanism movement that I want, right? So I created these generic parts so that they could easily be modified, and I assembled the parts together so that they can rotate. This mechanism can rotate and function, and I can see, it both in the sense of where it's going to pick up an algae and where it's going to deposit an algae, and depending on how far I go, I can see that this crashes, this geometry of the arm right here crashes into the rail, right? So I can make modifications to this geometry, and that's what we're actually going to do in this video. But putting this together, there's a couple of things I kind of learned about the design. One is that it kind of is fairly obvious in here, but these points have to stay within the geometry of the robot, right? The bumper can be there, but we need to stay within the rail. So the gym geometry had this kind of right at the bumper, and I needed to push this in so that the arm over here, when it's in its kind of initial stowed position, this arm would not be exterior to this. And right now, this bracket is a little bit over, but this is conceptual bracket, so it can easily be designed out of that with the point in this current position. Two, that when you're going through the movement, I had originally designed that this claw base should be kind of horizontal, picking up the algae. And when you're kind of looking at it, you can see that maybe even this could be coming at an angle kind of from the outer part in, right? So that you're trapping the algae between the floor and the bumper. So it could be vertical, but also if it comes in at this kind of towards the robot, I believe it'll also pick up the algae fairly well. And then the third thing is that the design for picking up the algae, so this mechanism, the geometry for picking up the algae is much more probably important than the geometry for depositing the algae into the center of the robot. So we put more priority on, how does this base react to picking up the algae versus, how is it deposited, right? I think we have more flexibility here. So that's kind of where I am. I wanted to show that I again made some modifications to the geometry, and now I'm at a point where I'm like, okay, this is decent geometry. Maybe I would push these points out even farther so I could take both arms and make them longer, and then this whole base would kind of sit out a little farther, and maybe that's something we could do. But I have these arms and I designed them with an offset in them. But this offset is a variable. And so as I've set it up now, this arm here probably doesn't need to have an offset, right? This arm probably could be less reduced, but this arm here probably doesn't need any. So we're going to go into this arm and make that modification. Okay, so that is the inner arm, and we'll open it up and we'll look at the front view, and we'll go into the sketch, edit sketch. So here's the sketch, and we're going to go to manage and look at the parameters. And you can see I've created a bunch of parameters that kind of mean something to me. But if we look here, well, let me close this for a second. Let's display the names. Okay. So when I created this sketch, I tried to create it with a set of variables that could be easily changed. So we have link length, we have offset distance, offset ratio here, which is where this offset is. So if offset ratio increases, it'll be more towards the outside. If it decreases, it'll be more towards the 0 point. Curve radius, the height of, I wanted, the points could be smaller than the actual, if there's an offset, it could be thicker in the middle. So what we're going to do, and hopefully this works, we are going to reduce the offset distance. So offset distance here is 2 inches, and we're going to make it 0.5. And there, the link is more straight. So we'll say done. We'll finish this. We'll save the part. And then we'll go back into our new system, and you can see that this is working kind of the same, right? And we also see that as we rotate this part here, the outer arm, also probably doesn't need to be offset as much. And so we're going to change that. We'll reduce that because when it's in this area here, you can see that it has a tendency to hit the rail. Maybe instead we're going to move the offset point out more. That might be a better option. Because what we also have to look at is, you know, this is just a 2D representation. At a certain point, we're going to want to look at this. How is this going to be in 3D? And in my first thought of this is this arm might be a fairly wide structure, and then this arm here might be a single arm in the middle. What we'll do is we'll look at this outer arm and we'll open it and go to the front view, go to extrusion, sketch, edit sketch. Now again, if we look at that dimension display names, we can see offset ratio. And I like using the parameters since I set them up. So I am going to is the link length times the offset ratio. So offset ratio is 171. And we are going to make this, oops, let me see, offset ratio, link length consumed by offset ratio. Oh, here we are. It's 0.2. Okay. So we're going to increase this to 0.4. Okay. And let's actually increase it a little bit more. This value is basically supposed to be between 0 and 1. 0 might cause it to crash, 1 might cause it to crash. But I think values, you know, between 0.1 and 9 are probably safe. We're going to say done. We're going to finish a sketch. File, save. And let's look at the mechanism now. So now we kind of have this, and it it can go a lot further before you crash in. Now it will be, there's a floor here, right? So again, we can reduce that offset and maybe just make it 0 on this one, right? This could be just a straight link. So let's go back to outer arm, go into the sketch again, edit sketch, and manage parameters. Offset distance. Hopefully this doesn't cause it to crash. Let's make it 0. Good. Done. Finish. We could probably make this completely, it's fatter in the middle. I'm going to leave that, but because the design of the link is far from finished. Save it and go back. And so here's our mechanism now. Again, the movement of the mechanism isn't really that important. It's not going to change because we haven't changed the hard points. We're just looking at how this reacts to kind of extreme rotations, right? It's almost like a pack, what we used to call at my company is a package type thing. As you move this around, are you going to crash into anything? Are you going to crash into the rail? And we can see right here that, yeah, moving this too far out, we did, we're going to crash into the bumper. So we're going to go back. We're going to go to manage parameters, and we are going to make this 0.5. And we're going to decrease this ratio back to, I don't know, 0.3. And did it take the 0.5? Yeah, it did. Okay, done. File, save. Come back to the mechanism. Now we have more room to bring it down before we start crashing again into the bumper. And we could probably, again, bring this farther back. So let's go back. Parameters. We're going to make this 0.1. And because of it's fatter, we're going to make this 1. Okay. Done. File. Save. Put mechanism again. Now you could see we could go down quite far. Right? Doesn't look, I don't know, I don't like it coming from so thin to so fat. Doing a stress analysis on this once we get the design, we'll see how thick this needs to be. But this looks pretty good. Probably this arm here could be a bit longer to push this so it's more down, right? Or we could change this claw base and change the angle between the two. Kind of have to imagine, like, what if you had this, instead of being down like this was kind of more, you just angled this up. So if you're here, this would be angled up. And that's probably better for depositing the coral. So there's two options I could go with here. Is I could move this out, and that would make this face more perpendicular to the algae, or I could just change this face. I don't think the way I set up this, I can easily change that. So I'll probably modify this design to kind of make that change. But probably also thinking that both arms need to come out a little bit farther. And if I do them together, it's just going to push this whole base out farther. And so, you know, we probably want the middle of this base to be, you know, the angle of attack between the middle of this base is probably going to want to be through the center of the algae, right? So these two could come out another inch, you know. Then the other is this angle change, and I'm probably going to make that angle change first. Really, and I'm not going to do it in this video. It'd take too long. But so if I have some more videos, we'll probably carry on from there. I'll make this change, and then once we get this solidified, we have to think about how this is going to work in 3D, right? This is really only a 2D type of model, right? This structure needs to, you know, have, you know, this algae is longer, and this structure would be quite weak, right, in this current configuration. This needs to have either two arms, which are exactly the same, and maybe this one in the middle, right, to have some stability along the z-axis. And you know, this would be longer because this is longer, right? So I'm going to end it here, and hopefully this gives some insight into how we're iterating on this design to make it perform better.